All right, this is Spencer and Brady, lesson 11, group problems. I'm going to go ahead and get it started for 1 and 2, and then Brady's going to take over and do the rest. Where are they at? Okay. All right, so for number 1, we basically just got these from notes and videos. So number 1's asking, this question concerns the molecules involved in translation. A, indicate the group of enzymes that covalently link amino acids to tRNA molecules, so aminoacyl tRNA synthetases. B, indicate 4 proteins that consume GTP during translation, IF2, IF3, EFTU, EFG, RF1, and 2. C, indicate 1 molecule that functions as a ribozyme during translation, and we got 23S rRNA. D, indicate 2 proteins that recognize stop codons, so we did RF1 and 2. E, indicate 1 molecule that forms hydrogen bonds with the Shine-Delgarno sequence in the mRNA, and we did 16S rRNA. Number 2, fill in the blanks. A, the first amino acid in prokaryotic proteins is F, MET. B, an E. coli protein called EFTU delivers charged tRNAs to the A site of the ribosome during translation elongation. C, the initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNAs bind to the A site of the ribosome. D, EFG, in mind all the underscores are supposed to be hyphens, is a translation factor that helps the ribozyme move 1 codon to the 3' direction along the mRNA. E, IF3 is a translation factor that guides the mRNA to the 30S ribosome subunit. F, the AUG codon is a start codon, while the UGA is an example of a stop codon. G, degenerate is a term that indicates that more than 1 codon can specify the same amino acid. And H, the final amino acid is located at the C terminus of the polypeptide. And let me just get rid of this screen share and give it to Brady real quick. All right, go ahead, Brady.
All right, so we're going to do number 3 now, which has to do with the wobble rules. So number 3 is a series of mRNA codons are indicated below. Consider the wobble rules and provide all possible tRNA anticodon sequences that can form hydrogen bonds with each mRNA codon. My phone's blowing up. Sorry. Someone won't leave me alone. Yeah, it's Spencer messaging me right now for all this. So A, the one that we are translating is 5' UUG to 3'. So we'll change that to AAU, and then it will be 3 to 5'. All these answers are going to be 3 to 5'. And now that I've mentioned the first one, I'll just read them off. So also on A, we have AAA, and we have AAC. On B, we're transcoding or changing AGU, so it's going to be UCI, UCU, UCA, and UCG. C is UAC, so we'll change that to AUI, AUA, and AUG. Having a heck of a time telling my letters apart here. D will be AUU, and we'll change that to UAI, UAU, UAA, and UAG. And E is GCA, and we'll change that to CGI and CGU. All right, moving on to 4. Suppose that E. coli contains a protein called protein X, which is 218 kilodaltons in molecular weight. So A is, if the average amino acid is 125 daltons, how many amino acids are found in protein X? So what you're going to do is take the 218 kilodaltons, which I have right here, which will be times 1 amino acid divided by 125 daltons. And this is your answer that you will get, 1744. For B, what is the length of mRNA coding region responsible for producing protein X? So you'll take the answer from above, 1744, times 3 nucleotides divided by 1 amino acid, which will give you 5,220 or 32. Next, we'll go to C, which says how many GTP molecules are consumed to synthesize each copy of protein X. So what you'll do is you'll have 2 times 1744, which is your first number that you had, plus 1 equals 3489. For D, we'll do how many ATP molecules are consumed to synthesize each copy of protein X. That will just be the original answer that we had. It'll just be 1 pretty much. E says, what is the name of the group of enzymes that consumes ATP to assist in the synthesis of protein X? And that is a word that is very difficult to pronounce. Aminoacyl tRNA synthetases. So we'll leave it at that. No more explanation with that word. And the last question is the list of proteins and acids that are involved in translation, and just you're adding them in if you think they belong. So these are the ones we thought belong. So A says, which of the above is involved in the translation initiation? So we have 16S RNA, Shine del Grano is how I'm pronouncing it. I don't know if that's correct. Then we have IF2 and IF3. We'll have tRNA, and we'll have 5' AUG to 3'. B is which of the above is involved in the translation elongation, which is 16 sRNA again. And then we'll have EFTU, we'll have EFG, we'll have 23 sRNA. And then for C, which of the above is involved in translation termination, we'll have RF1, and we'll have the stop codon also 5', UGA 3'. Which, for D, we'll say which of the above is a component of the 70S ribosome, and we'll have 16S RNA and 23S RNA. So looks like I'm missing my S right there. Maybe add that in. And then E, which of the above is found within the mRNA? So we'll have Shrine del Grano again. We'll have 5' UGA to 3', and we'll also have 5' AUG to 3'. And those are the ones that we chose based on what we thought was correct. So that's our lesson 11 group problems for Brady and Spencer. We are signing out.